Once again, welcome everybody to the Key Strategies to Ace the Chemistry Practical O-Level Revision Workshop. All right. Now, this will be the program outline for today. So first off, we will start off with the overview, just to remind you of some of the key requirements of the O-Level Chemistry Practical. Then next, we will go into reasons why some students do not score well in O-Level Chemistry Practical, as well as some of the common topics that are tested. And in each topic, I know that a lot of you have questions. Always you keep WhatsApp me, tell me, hey, how to do this question, how to do that question, okay? Even before the crash course, you're already asking me questions. Okay, good. That's good because it shows that you're very proactive at learning, and I thank you for that, okay? Thank you for taking one step out to be able to master chemistry. Okay, you're on the way. All right. Now, we also cover some key strategies to planning questions. This is something that I think many students are also wondering because planning question, I think, quite difficult for a lot of us. We don't really know how to approach or tackle these questions. And then I will also share with you this method, which is known as the AVPD method, okay, to approach the planning question. Okay, and this method is a foolproof method that you can use to approach any kind of planning question. And I'm very sure that you will be enlightened after you have learned this method. All right, and then after that, I will share with you some tips moving forward on how to best strategize for your O-level chemistry. Can I? Okay, if everybody is okay, good to go, can you type me 2 in the chat? Okay, thank you, Li Guo. Thank you, Doug. Thank you, Grace. Okay, thank you so much, everybody, so much for your warm response. All right, okay, let's get started for the session today. Okay, now to the basic. Okay, to the basic. The O-level chemistry practical, I think by now everybody will know it is 20% of your overall weightage. Okay, 20%. Now, 20% is not very small. If you think about it, 20% on the 2nd of October. On the 2nd of October, when you take your practical exam, that's it already. Okay, 20% of the mark is locked in already. Okay, so what I want you to do is in this 1 hour and 15 minutes, 1 hour and 50 minutes, okay, how are we best able to maximize our gains in terms of how to approach the chemistry practical so that we can get most marks, or how do we understand or answer the questions to the question requirement. Okay, now before I go on, just wanted to say for students who have questions, okay, feel free to type in the chat. All right, if you want, you can unmute and ask also. Okay, and just type in the chat. If you are shy, then I can address it at various points of the lesson. Okay, don't save your question all the way until the end. Then I have 200 questions at the end. Please, I will take a very long time to reply. Okay, so as and when the questions come in, when it's relevant, I will reply to the questions. Can I? Okay, so it's important for you to address your doubts at the first moment. Okay, so this is the scheme of assessment. Now, in the paper 3 practical, it will assess appropriate aspect of this. Okay, number 1, planning question. This one you don't need to copy. Later when I teach you stuff that need to copy, I will let you know. Okay, so all these are just run through with you first. Now, so you have a MMO, you have PDO, ACE. All of these, I think your school have gone through with you in terms of maybe telling you or letting you experience in the practical lab as well. Okay, now planning important is a weightage of 15%. Most of the time it is 4 to 5 mark question. Okay, planning is 4 to 5 mark question. So it's important for us to be able to get that 15%. If let's say that students who are unable to do well, okay, sometimes it's because their planning question you don't understand what it's trying to say. Okay. All right, but other than that, most importantly, the rest of this paper is 85%, and this 85% is very important. It forms the foundation of your score. It is definitely going to be quite substantial, right? So this is for practical experiments where you carry out the experiments, record the observations, draw some conclusions based on the observations as well. Okay. All right. Now, okay, coming to this. Key reasons why students do not do well. Tell me if you relate to any of these reasons, okay? I'll just give you some brief reasons. Not for everybody, but I think some of us may fall into one of the 3 categories over here. Okay, number 1, first reason is a lack of conceptual understanding. Now, for you to be able to do well in practical, it needs you to be good at your theory. You need to be good at your theory. That means that every concept in the textbook, you should be able to know, should be able to recall, should be able to explain. With that understanding, you are able to hence map it over to your practical. When the practical is talking about a certain concept, you know what it's trying to tell you. Okay, so that is number 1. Number 2, you are unable to apply what was taught in school. That means that in lesson, although yes, I'm paying 100% attention, I quite don't seem to get what the teacher is talking about or what they are trying to explain to me. But because of this, that's why I'm unable to actually conduct my experiment properly, unable to know how to record my observations, etc. And this will form a very huge pitfall. It's because of the fact that for some students, they do not know how to do this. That means that it will have implication on the score, it will have implication on the performance overall for the practical as well. And last but not least, this is some reason that some people are facing, which is to recognize popular exam trends or question types. Now, this is also quite important. Okay, every question can be broken down into topics. It can be broken down into how the question requirements are being asked. Okay, so to be able to recognize this is also a very crucial part, right? Because to be able to recognize the question, you are already halfway there. To know what the question is trying to get you to answer, you are already halfway there. Okay, and then after that, of course, we will now move on to the so how part. Okay, some of the exam strategy. So I understand that many students, either tomorrow, Friday, or next Monday, you all will have your prelim exam. Now, when you go for your prelim exam, I want you to be able to do well. And to be able to do well, I have given you some tips over here. Okay, if you want, you can write down. If you want, you can take a photo of this page, anything, okay, to make you remember. Now, in the pre-exam portion, which means before you sit for the exam, okay, what I'm doing today is to help you familiarize and revise with you some of the key topics. Later, we will talk about titration. It is inevitable that we talk about QA, speed of reaction, energy changes, etc. Okay, all of these are key practical topics which will high likelihood of coming out in the exam. After that, we talk about experimental procedures, which means that in the lab, are you able to know what to do? Do you know what is this reagent? Do you know what is the purpose of this reagent, etc.? Do you know what you are doing in your lab, basically? Okay, so this is important. You need to have a mental run through of, okay, what am I doing in the lab today? All right, experimental procedures. And last but not least, please, before the exam, calm your mind. Okay, don't be nervous. Okay, calm your mind. When you are nervous, everything seems so rushed. Everything seems so hectic to the point that the probability of me trying to understand the question because of my brain that's trying to spin and spin and spin because I'm nervous, right, is going to be very high, right? And that will mean that I cannot interpret the question properly. That will mean that the way they answer the question will also be affected. Okay, so it's important for you to calm your mind. Okay, for students, don't do last minute. Okay, before you go into exam, please stop reading planning question and the answer already. Please stop. You will never remember it. Okay, what you should do, revise the answering techniques. Later, when I drop a few drops of solution into this test tube, how am I going to describe the color change? How am I going to describe the formation of a precipitate? This is what you need to run through before the exam. Okay, now during the exam, you need to organize your workspace. Now, I have seen students in the lab, their things are all over the place. Their table, okay, their bench is like that, right? Then their answer booklet is here. Then they conduct the experiment here. Then after that, suddenly the answer booklet will come here. Then after the answer booklet go there, then after that the answer booklet will magically fall into the sink, or distilled water is going to fall on the answer booklet and whatever. There will be a lot of funny scenario. Okay, so what I'm trying to tell you is, when you are going for your exam, please ensure that you organize your workspace. And that's I know some of us are my student, right? So if you are my student, you have already heard me nag before. This is your bench. Your bench is very big. Either the sink will be on this side or on the other side, left or right. Okay, this one is tips for you to know, tips for you to study. Now, in the table, it's like that. Okay, the bench is like that, right? I will want you, if possible, to separate one side called the dry side, the other side called the wet side. Okay, so in this case, the dry side will be on the left because the wet side will be closer to the sink, easier for me to wash the apparatus. So on the dry side, what do I have? I have all the unused apparatus. Okay, unused apparatus. And I have my answer booklet. Okay, answer booklet on the dry side. This is my table. This is the top-down view of my table, the bench. Okay, on the wet side, what do I have? I have the experiment that is conducting. Okay, I'm conducting this experiment on the website. So that means that my person, your human will stand here to conduct your experiment. Once you get the result, go to the dry side, write down your result in the answer booklet. And then once you're done, go back to the website, conduct your experiment. Now, this is very crucial. It's because many of the times I see students, their chemical will spill onto the answer booklet, and then the answer booklet suddenly will mysteriously have a potassium manganese stain on it. Okay, so it's important for you to demarcate your workspace into a dry side and a wet side. The wet side closer to the sink for obvious reasons. If let's say anything you need to faster pour, you can pour straight into the sink. You don't need to bring across your answer booklet. Make sure you don't spill onto the answer booklet, right? Okay, so this is one of the very simple but very overlooked tips that students will actually benefit from. Huh? So if you want, you can write this down to record, to have a mental image. Now, I know that there's not much chance for you to practice already, because the next one is your prelim, and then the next one will be O-levels already. So in your prelim, if possible, you try out this. Then you see whether or not it works for you. Okay, one side is dry, one side is wet, and then we see whether it can help you to clear your mind as well. Because when the things are organized, right, okay, naturally our minds, our way of thinking is actually better, more streamlined. Now, next one, during the exam, read the question carefully. I cannot emphasize this enough. Read the question carefully. Now, I've seen so many students when they are in exam, they are very panicky, they are very rushed, and then they start glossing over important words. Then they tell you there's a sample B. They already told you what is the identity of it. Then later you are trying to derive what is the identity when it's already given to you in the first part of the question. Okay, so you read your question very carefully. If there are any things that is important, circle. Just circle the keywords. Okay, circle the keywords in the question. Okay, circle the keywords in the question. Now, this also brings me to my next point, which is answer to the question, which means if the question is asking for A, please respond A. Okay. Don't respond another thing. Okay. If not, you will not get the answer. Okay, and last but not least, clear your thoughts. Okay. The clear your thoughts over here doesn't mean mind blank. Not go inside exam, then mind blank, everything forget, don't know what to do. The clear your thoughts over here means identify what is this question trying to ask. The rest of the things in the question I throw, I just focus on what the question wants. Okay, what the question wants, I answer directly to the question. That is what is meant by clear your thoughts, so that you can answer to the question requirements. Okay, and of course, after the exam, okay, nobody care already. I just go and release your stress, okay, and then prepare for your next paper. Okay, so this is some of the very simple yet useful tips that I've crafted over the years, seeing how students go for practical and go into the lab and how they perform in the lab. Okay, now meanwhile, if you have any questions, please let me know in the chat. Okay, I'll be more than happy to answer them. We have around one hour, 1.5 hours to answer questions. Okay, so more than happy to do that. All right, now let's move on to this one that is quite important over here. Okay, now this one is one of the highlights of today's session. Now, in the next 40 minutes or so, I will bring you through some of the key topics and skills that are required for practical. Okay, now, topics-wise, core experiments. Okay, we have a few experiments over here. This one you might want to take down. Now, under core experiments, we have titration. Now, this one I think very standard. Most students will know that titration will be tested, okay, or high likelihood for it to be tested. Now, acid-base titration, redox titration, they are the different type of titration that can appear as well. Okay, now similarly, moving on, there is going to be chemical energetics. Now, chemical energetics can manifest itself in a few different ways. For example, maybe it can tell you to measure the energy change when I add a solution A to a solid B. Okay, I pour the solid B into solution A, I use a thermometer, I measure the temperature rise. So this is what is known by chemical energetics experiment, where I measure a certain energy change. All right. Okay, then we have speed of reaction. Now, speed of reaction is also fun experiment. Okay, for example, if let's say that I have this beaker over here. I have a certain chemical, maybe Q. Okay, then I'm going to add chemical P inside. Okay, and then I'm going to record maybe the mass loss. Okay, mass loss every 20 seconds. So these are some type of ones that I can actually try to find out what is the speed of reaction. Some of the experiments that they can potentially test you for speed of reaction. Then moving on, we have QA. QA very standard. In a sample, what am I trying to find? I'm trying to find what are the cation, what are the anions, and these are done through the analysis of my different tests. Okay, I conduct addition of aqueous sodium hydroxide, aqueous ammonia. Okay, all of these will help me to identify, okay, what is involved in one particular substance. And last but not least, salt preparation. Now, salt preparation is one that is not so frequently tested, but it can still be tested. Okay, you need to know how to do crystallization of salt, which means using of your redox stand with a crystallizing or evaporating dish on top, and then of course your Bunsen flame below. Okay, anybody here are still scared of turning on the Bunsen flame? I think some of us are quite afraid, right? We have never on the Bunsen flame, or Kazu, I saw your raised hand. Okay. Some of us we have never on the Bunsen flame before in our whole life, because in lessons we ask our friend help me to on the Bunsen flame. Then in exam I panic, I don't know how to use the lighter. Some of the students are like that because you don't have the exposure to how to use the Bunsen flame, right? Then it's a bit restrictive for you. And in exam, it gives you a more stressed atmosphere, right? Because you don't know how to on the Bunsen burner, and that creates an issue as well. Then after that, when you try and light the Bunsen flame, then the flame don't light, then you will be there. Is there something wrong with the lighter? Is there something wrong with the gas tubing? Is there something wrong with the Bunsen burner? Then all of the different questions will come in, okay? So in prelim, if you have a few chance, go and light a few more times. Practice a few more times before your O level, okay? At home, please don't use your gas stove as a Bunsen burner, okay? Please don't burn down your house. I'm not responsible for anything, okay? So please do in the lab. Okay, okay. And next, by extension, okay, mole calculation. This is important as well. Now, can anybody tell me in mole calculation, which is the core experiment that will require mole calculation? Okay, Chloe, I saw a question. Ligo, I also saw a question. Okay. Can anybody tell me mole calculation come out in which one? Yes, very good. Titration. Okay. Okay, thank you, Chloe. Thank you. Okay, thank you, everyone. Okay, so mole calculation, most of the time, it come out in titration. Okay, and in titration, it needs you to be able to recall what are the formulas involved in mole calculation. Okay, how do you convert from MR, okay, to mass? How do you convert from concentration to volume? Okay, etc. All of these different formulas, you need to have awareness of it as well. Okay, all right. I have a question over here. Okay, from Chloe. Okay, can everybody later when you all type, okay, type to everybody so that everybody can see your question. Okay. We are all here to learn, so don't need to be afraid. Just type to everybody so that I don't have to repeat the question. Okay, yeah, everybody can see the question in the chat. All right. So Chloe asks, will electrolysis be ever tested for pure chem practical? Answer is highly unlikely because you must remember, MOE need to supply to 37,000 students. I cannot be supplying one setup where I have 2 electrode, then I have 1 battery, then I need to train all my invigilator to know how to operate that thing if the thing fail. Okay, so most of the time we will not use electrolysis, or rather 99% of the time you will not see electrolysis come out practical at all. Okay, reason being high cost, and it's very infeasible for the MOE to be able to supply to everybody lah. Okay, and it's also very power consuming. Maybe your school lab, the PowerPoint might be overloaded for some of the older schools. Okay, because electrolysis requires a lot of energy. Okay, remember, electrolysis is conversion of electrical energy to form a chemical reaction, a redox reaction, right? Okay. All right. Weightage for pure chem or combined chem practical is different. Okay. Combined chem is with your science, with your other science, okay, or with your other contrasting science, but pure chem is 20%. Okay. Will thermal decomposition be tested? Yes, thermal decomposition is also one of the key topics that might be tested. Okay, and they ask what are some cations, anions that are unlikely to come out. Wow, this one difficult to predict, you know. Okay, it's like asking me, today I go McDonald's, which one I feel like eating? Okay, which burger I feel like eating? Okay lah, but rule of thumb is this: you have your QA table, right? Even if they give you something that is out of the blue, it will still be somewhere on the QA table. Okay, just go and refer, should be fine, right? Okay, the QA table is a backup, it's not your primary. Okay. All right. Okay, Liko, yes. Okay, now under skills, let's move on to skills already. Later I answer the questions later. Okay, I know you all have a lot of questions, which is good. Okay, under skills, now data presentation is one. Now, data presentation most commonly, okay, is in the form of a table. Most commonly, it is a form of table. And table will manifest itself in terms of recording of temperature. This can be one, okay, recording of temperature. Okay. Recording of temperature over time. Okay, table can also be for titration results. Okay, there are many purposes for tables. Basically, you need to know what are some data presentation tools, for example, like a table. Okay, of course, another one very common will be graph or graph drawing, okay, which is I put as a separate item over here. Later, we will run through what are the requirements for graphing as well. Okay, now there'll be calculations and application of relevant chemistry formula. This one is very standard across all topics. Okay, and last but not least, I think most of us are here. Can you give me a thumbs up if you are here for the planning segment? I should expect to see 3/4 of the people give thumbs up. I see Chloe, I see Ingrid, Izadi, Jiahui, Jinxian. Yeah, everybody is here for planning. Okay. Okay, planning is one part that I think is quite problematic for some students. Okay, hopefully after today's session, later when I teach you some of the techniques, you will be able to approach planning slightly better. Huh? Okay, don't expect 100% miracle change. I don't need to be here. Sorry. Okay. Sorry, Catherine, I mute you. Okay, all right. So as I was saying, I don't expect 100% miracle change. If 100% I won't be here. I'll be somewhere selling some video marketing to people that, hey, this is a fantastic strategy for you to study for. Okay. Okay, so the point over here is I try to help you, okay, as much as possible. Ask your questions later. Then after that, let's try and benefit from each other. Huh? Okay. All right. So these are key practical topics and skills. It's a non-exhaustive list. That means that they are more. Okay. But based on exam trends, these are the topics that have been occurring. Okay, that have been occurring. And what is important is you need to know how to approach each of these topics as well. Okay. All right. No worries, Catherine. Okay. Yeah. Okay, Diane have a question. Okay, how will I know what gases to test? There are so many tests. Okay, what are the gases that are most likely to come out? Okay, listen, later we will go through as well. All right? Can Okay, by the way, okay, everybody, just to tell everybody, please take note. Sulfur dioxide gas, okay, is not tested. Okay. Sulfur dioxide gas is not tested. This one, just for your knowledge, is not tested. Do not need to carry out any experiment based on sulfur dioxide gas. There will never be a requirement for you to do that. It is because sulfur dioxide gas is poisonous. Okay? All right, so it will not be tested. Can I? Yes, it's in your notes. It's in your notes. It will be in your notes, okay? Because you actually, by right, in theory, you need to know how to test, okay? Which means using your potassium manganate, and then after that, using of a filter paper in deep potassium manganate, okay, and then it will decolorize. Okay, now the sulfur dioxide gas you need to know, but it do not need to be tested. Okay, because for a simple reason, in practical, if there's everybody producing sulfur dioxide gas, I think you will get gas poisoning. Okay, not so bad, but it's bad to inhale the gas. Okay, it's bad to inhale the gas. Okay, large amount of the gas. Okay, let's move on. Now, I'm going to go to the first topic first. Now, I'm going to go by topics now. So we are going to cover titration, energetics, etc. Okay. So in this one, it's important. You have a blank piece of paper and then you write down all the important knowledge. Okay, come. Let's do some revision on titration. I need you all to help me with this. Okay. Later I'll come back to Diane's question. Okay. If I forgot, can you please help me to arrow? Okay. Thank you, Andy. I saw your arrow already. All right. Okay, come. Titration, okay, back to titration. Okay, first thing, in titration, sometimes the question might not say the word titration, they might say volumetric analysis. Okay, this chapter is known as two names. One is called titration, the other one is known as volumetric analysis. Okay, both of it are the same thing, refer to the same thing. Basically, I'm trying to react one acid with one base. Okay, one acid with one base. And the whole premise of it is I'm waiting for that indicator to change color, okay, to change to the endpoint. All right, so it's known as volumetric analysis. Now, can anybody tell me what is the most important three pieces of apparatus for this experiment? Type in the chat. What is the most important three pieces of apparatus for this experiment? Okay, good. Thank you, Xavier. I saw burette. Okay. Mukundan, I saw pipette, burette, conical flask. Very good. Jinxian burette, good. All right. Liquor burette, pipette, conical flask. Fantastic. Okay, Andy, pipette must spell correctly. Okay. Okay, so let's write down. Now, precision of apparatus, I'm going to go through with you. First, we go through burette. Burette is the most common apparatus along with pipette. Okay. And last one is the conical flask. Okay. Now, first off, just want to let you know, conical flask no need precision because conical flask, it is just a reacting chamber whereby I put all the chemical inside, it is just going to react over there. There's no measurement used there. Okay. Now, first off, can anybody help me for burette? What is the precision? How many dp must I put into? Anybody type to me in the chat. Okay, Li Guo say 2 decimal points. Xavier say 0.1. Okay, Jin Sen say 2 dp. Okay, Aziza say 2 dp. Jia Hui say 1 dp. Grace say 2 dp. Andy say 2 dp. Bernice, Brandon, Caroline, CC, Christabel, any answer? Okay, Chloe say 2 dp. Okay, all right. So burette reading, you must always put to 0.05 cm cube, which means you must always put to 2 decimal place. Okay, burette, you must always put to 2 decimal place. Okay, then the next one. What about pipette? Pipette got marks one, got readings one, or is it just one fixed volume? If fixed, tell me fixed. If vary, tell me vary. Okay, good. Mukundan says fixed. Okay, Xavier says fixed. Okay, Li Gua at 25.0. Okay, good. All right, fantastic. Good. Okay, so pipette will always have a fixed reading. Okay, we'll always have a fixed reading. Okay. Now, in chemistry, or rather in O-level chemistry, most of the time, most commonly, we will use 25.0 cm cube pipette. Okay, 25.0 cm cube pipette. Now, there are some scenario, okay, in some of the years that they did not use, yes, Chloe, thank you very much, that they did not use a 25 cm cube. Then the students shocked because they see the pipette, why the pipette is so small one? Okay, it is not the normal one. It is actually a 10.0 cm cube pipette. Now, so the moral of the story over here is this. When you go into exam, if let's say the normal pipette that you used to see, right, becomes smaller, becomes shrink in size, right? Don't panic, okay? It is meant to be that way. Cambridge never give you anything wrong. Read the apparatus list. When it says 10.0 cm cube pipette, then they give you a small one. That's correct. Okay. Now, some exams require you, or rather some experiments require you to use a smaller pipette, okay, because of the ratio to the different chemicals. So it is normal. It is normal. If let's say you go into exam when you suddenly see a different measurement of pipette, right? Okay, just need to know this. Always remain calm. Look at what they give you. Okay, so either it is a 25.0 cm cube pipette or is it a 10.0 cm cube pipette? Okay, can Okay, very good. So we have already settled what is the precision of the apparatus and conical flask. Now, my next question to everybody. When I prepare a titration setup, listen to my question carefully. Which are the pieces of apparatus that I need to rinse with distilled water? Is it just a conical flask? Is it pipette? Or is it burette? Or is it all three? Which one I need? Which are the ones that I need? Okay, hint to you, which are the ones that I need to rinse with distilled water? Yes. Okay, good. Thank you so much, everybody. I see all as an answer. Okay, so the key over here is this. The first rinse, okay, you'll wash either with tap water, then you'll move on to using distilled water. Okay. If you cannot see my writing, please let me know if the color contrast. Okay. Now, after I rinse with distilled water, which are the ones that I need to rinse with chemical? Okay, Mukundan says burette, Andy say burette. Okay, Aziza say pipette and burette. Okay, Digo say burette. Grace say pipette and burette. Chloe say, okay, very good. Okay, so majority of you got it. So pipette and burette, the step number 2 is you need to rinse. Okay, with chemical. Okay, the solution Q or solution P or solution X, solution Y. All right. Now the question is this. Question will ask you, why is it that I will not rinse the conical flask with chemical? Why is it that we will not rinse conical flask with chemical? Anybody know why? Yes, okay. So we will, if we add water, yes, Kazu, yes. Distilled water is deionized water, correct. Okay, O level, we normally use distilled water. Okay, come. Conical flask, we don't rinse with chemical, okay? So that we will not be contaminated, right? So it will be pure, okay? It will not affect experimental result. Okay, it will not affect the experimental result if we just rinse with distilled water. Okay, Sinan, what do you mean by rinsing with chemical? My teacher have never mentioned this. Okay, so when you start off your practical, right? Okay, on your table, there's a pipette, there's a pipette. Now, when I start, before I do anything, I don't just pour my chemical inside and call it a day and start titrating already. I need to wash my apparatus first, right? I need to clean the apparatus first, right? So can you see over here, in the pipette over here, first wash, I wash with distilled water. Now, after I wash with distilled water, the next step, because there is still remnant of distilled water that is stuck on the wall of the pipette and whatever, a lot of remnants, right? Remnants of water. What I'm going to do is that I'm going to pour in the solution. Okay, the solution. But maybe let's say this one is X, then the one inside the conical flask is Y. So I'm going to pour solution X inside the burette, and then I will tip it over so that I can rinse the inside with solution X first. Then I pour the solution out. Then after that, after I rinsed it, I will pour in my solution X again. Okay, solution X again to fill it up to zero mark. Okay, so to rinse the chemical is to ensure that the number of moles or the concentration of the reactant over here, okay, concentration of the reactants over here is whatever that the solution is trying to give you, right? So for example, 0.1 mole per dm cube, right? The question give you, but if let's say that there are some water inside, it might change the concentration, maybe 0.085, something like that. Okay, so we don't want that, hence we need to rinse with the chemical, with the solution. Okay, can. Andy, yes, we pour to full. Okay, we will pour to the 0.00 cm cube mark. Okay, for your first titration. Okay. Okay, now okay. So back to this one over here, the chemical itself. Now we come over to the titration table. Okay, we come over to the titration table. Now there are some things that I want to emphasize over here for the titration table. Now, the first two row over here. On top, is it final or initial? Below, is it final or initial? Number one, this one over here, is it final or initial? Can anybody tell me? F or I? Final or initial reading? Okay, Chloe say final, Jin say initial, Grace say final, Brandon says final, Jiahui says initial. Okay, Mel says final. Okay, so the correct answer for this on top, your first one must be final. Okay, final bureau. Okay, and then the one below it must be the initial burette reading. I will explain to you why later. Okay, so draw the titration table out first, then we write down this one. Okay, we write down this one as a form for revision lah. Okay, So we are writing on a blank paper. Sharice, I saw your question. Okay, we are writing on blank paper. We are just annotating on blank paper. Okay, so you just annotate what I write down. Okay, just get pen and paper. When you will they ask for definitions of acids, etc. Huh? Okay, you are taking a practical paper. Chances are likelihood not lah. Okay, but there was 1 year that they asked for what does the term isotope mean in the practical paper. So I cannot 100% tell you no. Okay, but I can also 100% tell you yes lah. Okay, most likely is don't have one. Most likely is don't have. Okay, what does titration number mean? That means I have one titration over here, two titration over here, and three titration. Okay, for example, like that. Okay, so we are conducting this volumetric analysis multiple times. Now, for my combined chem students over here, I think some of you might not be super familiar with titration. Okay, simple reason because your school might not have conducted it multiple times with you. Okay, maybe you'll just do it once, or some school they never do before. Okay, but it's okay. Later when we go through QA energy changes, these are some of the reactions that you probably have done before. Okay. Okay, so for the simple reason, back to this for all students, table of results, final period reading, initial period reading. Initial period reading for your first titration, can you tell me, this initial period reading, is it 50.00 or is it 0.00? Type to me in the chat. Okay, Grace says 0, Nicole says 0, Andy says 0, Xavier says 0, Ingrid says 0. Okay, very good. Everybody is correct. 0.00. Now you must remember time and time again. I remind you, burette readings are opposite. On top is 0.00, below is 50.00. Okay, so it increases downwards. It increases downwards. Okay. I have a question from Mukundan. What are common source of error? Later we will go through. Okay, this one I know some of you are also be asking. Okay, so for example, if let's say the final burette reading is 25.40. Okay, then the volume of maybe solution Q used. Okay, hence I will take the final minus the initial. This is how I present my working. The final will minus the initial, and hence it will be 25.40. Okay, this is how you present your results. And this is a very important part also. Just now when we are talking about the syllabus requirement or the exam requirements, okay, over here. Okay, presentation of data and observation. This is very important. Okay. All right, back to here. Okay, Grace, I saw your question. Okay, give me a while, I will address this question. Okay. Mukundan also, give me a while, I'll address your question. Okay, everybody copy this one already, Okay, now let's answer these questions. So for burette, can anybody tell me maximum volume capacity of a burette is what? 50.0. Thank you, Lipo. Okay, so maximum volume, maximum capacity of a burette is 50.00 cube. Now, most of your time, the titration results for O levels, normally it will be around 20 to 27. This is an estimated reading. Most of the time, it will be around 20 to 27. So for Mukundan, I think your answer is no lah, or because Mukundan asking whether or not can we initially fill half the period only to save time, so that we don't have to start from 0. Answer is no, because if let's say I fill half the period, I only got 25, right? Then my titration result is actually 27. Then I got not enough chemical to run my titration to get to the endpoint. Can you see that? Okay, Grace, yes, correct. Okay, initial period reading can be between 0 to 10. It can go even up to 15 also, okay. Okay, now, key strategy, okay, key strategy time. Question, if let's say I conducted experiment number 1, the volume of Q used is 25.4 cm cube. What is the volume of solution remaining in the burette? Can anybody tell me? Do some quick math. 24.6, okay, thank you, Lipo. Okay, Jinsen, thank you. 50 minus 24, 5.4. Okay, good. So 24.6 is not sufficient for you to carry out experiment number 2 without topping up, right? Okay, so what I will advise my students is this. If you have a burette over here, inside is maybe let's say inside it contains solution Q. Then my solution Q is already inside the plastic bottle that they provide to me. Okay, this one is my solution Q. I will have the plastic bottle on standby. When okay, bring me back to one important point. Please never ever leave the filter funnel. Please never ever leave the filter funnel. Because if let's say my filter funnel is here, there is residual chemical, and then I saw this is 0.00 already, then the residual chemical drip down. What happened? Then it will cause the reading to fail, right? Okay, so please remember, whenever before conducting any experiment, okay, this is one of the tips that I want to share with you also. Visually check, okay, the experimental setup before starting every experiment. Okay? Can I? Shari's filter funnel can wash with a chemical, can rinse with chemical. Okay? Can rinse with chemical. Okay. Okay, back to this. Now, if Q is over here, the plastic bottle is here. Do we need to cap it? Yes, answer is yes. Because sometimes they will escape. Okay, some of the chemical is volatile. What do I mean by visually check? Okay, so back to just now my story with the table, right? So this is your bench, right? This is your bench. Your experimental setup is here. Maybe your burette is here, okay, on the clamp. So you are here looking at the readings. Now, before you start the titration, I want you to take one step back. Look at your whole setup. Look at what you have just prepared over there. Is it correct or not? Is there anything that is wrong? Visually check means, is the solution inside correct? Is it Q or is it P? You need to know you put the correct solution. Over here, have you done your drop of indicator? Have you added your drop of indicator? Have you poured 25 cm into the conical flask already? So this will help you to minimize the chance of error. If let's say, for example, I put an empty conical flask over here and I start titrating, that will not be very nice, right? Because the readings will be affected. Okay. All right. So my advice to you is keep the Q on hand. After you finish your first titration, my advice to you is very simple. Refill the Q all the way until the 0.00 cm cube mark again. Okay, all the way back to 0.00 cm cube mark. This is my recommendation. You can take it or you can leave it, up to you. But my recommendation to you is fill up to 0.00 cm cube because it will help you in terms of just now I stopped around here. Later, I'm also expecting my endpoint to stop around here. So that means I know that over here, I can start to slow down my titration, right? Remember, I need to on the tap, off the tap, on the tap, off the tap, right? Okay. So in this case, when I start from 0.00, that means that the final period reading will always end off at the same place on that same period. That means what? That means more confident, because you know that your readings are so far so good. Okay, so far so good. So for example, if let's say I get 25.20, that is my another reading. So, and for math, also very easy, right? Because I can just minus 0. It will give me the volume of Q. Okay. Examiner observation counted, no. Okay. Caroline, I think I answered your question. Leave the lid open, not recommended to lah. Number one, sometimes the chemical may evaporate. Number two, for a very simple reason. If the lid is left open, if let's say I'm not careful, I knock down, then my answer booklet gone also. Okay, so try and cover the unused chemicals. All right, can okay, Aziza, later I address your question. Okay, can okay, so okay, back to this. When I have two titration results, how do I know whether to go on to a third titration or not go on to a third titration? Can anybody tell me? Can anybody tell me? Okay, good, Mukundan. If the results are too far apart, inaccurate readings. Okay, yes, okay, great. If the results are not within 0.20, okay? So if the results, okay, are within 0.20 cm cube, then yes, it is a good titration, and I will put two ticks over here. Okay, I'll put two ticks over here to represent that I am taking these two titration results. Can okay, my recommendation to you is this: if your first two, okay, if your first two titration result is within 0.20, then you can just move on already. Don't need to repeat the experiment again. Okay. Chloe, isn't it 0.1? O level is 0.2. Okay, O level is 0.2. If you are from IP, then yes, 0.1. Okay, for IP student, school might practice 0.1. But for the rest of us, generally O level, we always stick to 0.2. Okay? Can Okay, so this is for table of results. Any question for the table? If no question, can you give me a thumbs up? And I know that I can move on. Okay, thank you, Ingrid. Thank you, Isati. Thank you. All right. Thank you, Jiahui. Thank you, Kai Qi. Okay, very good. Nice. Okay, so now we go to the indicators. Okay. Now, indicators, there are many types. Okay, can be methyl orange, can be thymophthalate, can be phenolphthalein. There are many indicators that sometimes your school never teach you. Okay, but not to worry. If they give you something that is out of the blue, if the indicator is something that we have never seen, it is not a common indicator. SEAB will tell you, okay, the paper will tell you that this is the color change you're looking out for. At the end point, one drop of solution Q turns the solution pale blue, something like this. Then you know that the endpoint is when the solution is pale blue. Okay, so indicators, methyl orange you need to. Okay, in acidic, it's red. Okay, at endpoint is orange. Okay, same goes. Now the question, next one is this. Under indicators, why? Okay, first question. Can universal indicator be used for titration? Can you tell me yes or no inside the chat? Can we use universal indicator? Okay, Ingrid say no, Mel say yes, Xavier say no, Grace say no, Aziza say no, Jiahui say no. Okay, so generally answer is no. Cannot use universal indicator. Why? Why we cannot use universal indicator? Does anyone know? Okay, for titration, why cannot use universal indicator? Yes, okay. Thank you, Aziza. Thank you, Mel. Okay, good. Okay, Mukundan not really unwanted reactions, but it's more so the color changes. Okay, so we cannot use universal indicator. It is because of this. It is because universal indicator changes gradually. Okay, gradually over a range of pH. Okay, and in titration, what are we looking out for? In titration, we are looking out for the sharp color change. Okay, the sharp color change is required in titration. Okay, and hence, because if we use universal indicator, it will not give us this sharp color change. Okay, so this might be a common question. Why they will ask you why we cannot use universal indicator for titration as well. Can okay. All right. Andy, to your question, yes, for combined chem. Okay, yes, no need. Okay, next, let's move on. Okay, any more question on titration? If not, we move on to the next one already. Okay, if you have any question, you let me know. Okay, so make sure you copy down. If you need to take a photo of it, I give you 10 seconds. Okay, faster take a picture of this screen. Then we'll move on to the next part. Okay, all right, so this is for titration. This is the revision for titration. Now, we got yes, common indicator you need to know. Okay, for methyl orange. Most of the time it's methyl orange. Okay. Okay, next one. Let's move on. Speed of reaction and energetics. Okay, this one is quite common. Okay, speed of reaction experiment are quite common because it's very easy to conduct. So schools might choose to put in speed of reaction questions. Sometimes the question can be more challenging. Sometimes the question can be simpler. Now, for common apparatus for speed of reaction kind of experiments, okay, Gwen want to go back to take a screenshot. Okay, I give you 5 seconds, Gwen. Okay, to take a photo first. Okay, as I'm saying just now, okay, so speed of reaction is quite common. Okay, what is important for speed of reaction is you need to know what are some common apparatus as well as how to draw graph. Okay, so these are the two important things for speed of reaction. Okay, Gwen, you take screenshot already? Can I? Okay. Okay. Sharis have a good question for planning question. If let's say they ask you to plan a titration question for planning, how do you know whether to put in the acid or base for the burette? Okay, that one is up to you. Okay, you can choose. Okay, for a planning question. Unless the question got specified lah. Okay, using a titration method. Okay, titrate P against Q, then P must be in where? Burette or pipette? Burette. Okay, so P must be in the burette. Can I? Okay, so this is for this one. Now next, we go on to speed of reaction and energetics. Okay. Later I come back to your question, Doug and Andy also. Okay. So we go on to speed of reaction and energetics first. What are some common apparatus? Can you tell me what are some common apparatus for speed of reaction and energetic? If I need to calculate speed, what do I need? I need to measure time. With time, what do I use? Yes, very good. Thank you, Jin Xian. You need a stopwatch. Okay. Now, if let's say I'm reacting a solid, a carbonate with an acid, I react a carbonate with an acid, I'm expecting to get carbon dioxide gas, right? So for me to measure carbon dioxide gas, what do I use? What is the apparatus that I use? I need to measure the volume of carbon dioxide gas produced. Yes, thank you, Xavier. Thank you, Rico. Okay, good. Yes, strange. Okay. Now, if let's say I want to measure changes in mass, what do I use? Yes, electronic balance. Very good. Okay. Please don't say weighing scale. Okay. Please don't say measuring balance. Keyword is electronic mass balance, or you can just tell me electronic balance is good. Okay, so these are some common apparatus. Now, for speed of reaction or energetics, it's very simple. Actually, the apparatus precision is very simple. Just see on the stopwatch or see on the electronic balance. Okay, electronic balance show what, you just copy down the exact one. Okay, don't go and round to anything. That is the precision of the instrument. Keep it as this. Okay, all right. Okay, so this is for speed of reaction. Now, when we are drawing a graph, okay, now there are a few things that I want you to take note. But before we go to graph drawing, maybe we come to sources of error first. Okay, maybe we come to source of error first. Now, common apparatus, there's still one more. If I measure changes in temperature, what is the measuring apparatus that I use? Thermometer. Very good. Okay, now under source of error, I just want to cover a few with you. I'm going to write on the right side over here. Now, and for sources of error, there can be quite a few. Now, I will not recommend that you memorize source of error. Reason is very simple. If you memorize source of error, then the scenario is not fit to the question is trying to ask, what the question is trying to ask. Then your source of error cannot work already. For example, if let's say before you begin the experiment, ensure that you are in an environment with no wind. Then like that, you cannot say, please turn off the fan, right? You conduct an experiment in enclosed environment. That's already given. Okay, that's already a given by the question. So you need to answer, for sources of error, you need to answer to what the question wants. Okay, the question requirement. And this requires you to read closely. Okay, and this requires you to read closely. So how do we study for source of error? Then I tell you, hey, don't memorize. How? Okay, we classify by which kind of apparatus? We classify by the type of experiment. Okay, so for when it's involved, I give you just a few examples. Okay, you just study them. Just know that this apparatus can create this form of error, or this type of experiment can create this form of source of error. Okay, now stopwatch, a very simple source of error, number one, is human reaction time. Okay, so human reaction time, which means you need time to press the stopwatch. Look at the experiment. Okay, the experiment start already, I press the stopwatch. Then there will be a time like maybe 0.3 seconds, 1 second. Okay, for stopwatch. Now, gas streams, normally there are not really a lot of source of error, but there might be one source of error. Okay. So source of error may be if the gas stream is not properly lubricated. Okay. If the stream is not properly lubricated. Now, what does that mean? If let's say I have a gas stream that the stream cannot move on. If the gas stream cannot move, okay. Sherry's how to use gas stream. Very simple. If I have a conical flask over here, this is my oops. This is the conical flask. Okay. On top, I have a rubber bung, rubber stopper. Okay, this is the gas stream. Okay, normally the gas stream will be connected to, it will be capped. Okay, it will be capped on the retort stand. Okay, it will be clipped on the retort stand. And then there will be a plunger. And this plunger is supposed to move freely. Okay, it's supposed to move freely. So if it doesn't move freely, it means there's some friction involved. The gas that is being produced pushing against this plunger will not be able to move it. And hence, the volume of gas will be affected. So it's important for you to know when we are talking about source of error, okay, source of error, you need to know what kind of reading does it affect. This affect the time. Okay, this affects volume of gas recorded. Okay. Oops. Okay, I am looking at Mukundan's question. Is human reaction time classified under human error? Is it wrong to write human error? Human error can be many cases. Okay, first human error is I don't know how to use the apparatus. That one is my error because I never studied how to use the apparatus. Human reaction time, okay, is reaction time that, or rather, is an error created by humans using the stopwatch. So, if there is a stopwatch involved and when it is used to measure time, okay, a duration of a reaction, then yes, human reaction time is one error. Okay. Now, another one is electronic balance. Electronic balance normally, okay, no error one. Okay, unless it's not properly serviced lah. Okay. Sorry, give me a moment. The screen a bit is slightly lagging. Okay, give me a moment. Okay. All right. Okay. Okay, everybody, can you see my screen? Can you give me a thumbs up if you can see my screen? So sorry, there's some lag over here. Okay, good. Everybody can see my screen. Fantastic. Okay, great. Okay. So back to here. Okay, source of error. For thermometer, source of error is this. This one is very popular. Heat loss to surrounding. Okay, if there's a measurement of temperature involved, this will affect the measurement of temperature. Okay, measurement of temperature. Can Okay. Any question? Anybody have any question? Okay, these are some of the basics. Okay. It's not tearing a source of error, but that one can be easily solved that you just press one button. Normally, electronic balance, no error. We say that electronic balance because it's a digital tool, there is no source of error. Okay. Source of error normally arise when it cannot be simply rectified. Okay, so for example, like human reaction time, I cannot simply rectify it. Okay, proper solution maybe is to conduct a few times and then I average the results, right? That is one of the ways, but there is no simple solution. For example, like using a measuring electronic balance to measure something. That one I can just simply tear the machine, right? Okay, good. Yeah, with that, that's all I want to run through for speed of reaction and energetics. Yeah, a reminder when you are conducting energetics experiment, be very careful. All right, especially for this one, measurement of temperature. Then they ask you what are some improvement. Okay, improvement means you can use maybe when you use heat loss, or rather when you measure temperature, heat loss to surrounding. If you are conducting in the plastic cup, maybe use a styrofoam cup. Oops. Okay, styrofoam cup. Okay, because styrofoam is a better insulator of heat, right? Okay, poorer conductor of heat. So I use styrofoam cup slash, if I'm already using a styrofoam cup, I will use a lid on the cup, okay, to prevent any kind of acid spray slash heat loss to the surrounding air. Okay, can now if let's say that there is some question that requires you to stir, okay, requires you to stir. Inconsistency in stirring, okay? Stirring a solution is also a source of error. Okay, means I take a metal rod, then I start there stirring the solution, or glass rod, there stirring the solution. But the rate of me stirring the solution is not accurate. I can sometimes stir maybe 3 rounds per second, 2 rounds per second. Okay, this is inconsistent. So what is a way to combat this or rectify this? Simple. Okay, use magnetic stirrer. Okay, now magnetic stirrer is a very interesting tool. Basically, okay, it is on the metal plate. Okay, the beaker is on the metal plate. There is a magnetic stirrer here. Now there's a motor that is inside the device. Okay, that is going to attract this magnetic stirrer. So when the below spin, the on top will also spin. So it will regulate the rate of stirring. Okay, of the solution in the beaker. Okay, it will regulate the rate of stirring of the solution in the beaker itself. Can all right, if all good, can you give me a thumbs up so I know that I can proceed to the next one? Yeah, thank you, Ingrid. Thank you, Jiahui. Okay, thank you so much, everybody. Okay, I see your thumbs up. Okay, let's move on. For students who want to take a screenshot of this, okay, you have 10 seconds. Please take a screenshot. Then after that, we will move on to the next one already. Okay, can I? Okay, now let's move on to QA. Now, QA, sorry, the green is really very bright. Okay, but it is to catch your attention, right? Because I know that 1 hour already, some students already going on. Okay, especially it's 9 p.m. in the night after a long day of school. Okay, but I thank you so much for taking time to come for the session so that you can learn together with the rest of the 50 students over here. Okay, so give yourself a pat on the back for being so on the ball for coming down over here to study practical techniques with us. All right. Now, okay, this one is a popular one as well, QA, qualitative analysis. Now, QA, okay, sometimes students like it, sometimes students don't like it. Like it because very simple. I just follow QA table, I drop a few drop solution, I write down observation, that's it, finish, end of story. Sometimes students don't like it. When the color come out is a very weird color, I don't know what the color is trying to show me. That's when you are confused. That's when you don't know what is going on inside the test tube. Is it supposed to be reddish brown? Is it something look like purple? Sometimes look like dark blue? Okay, yeah. So what do you do for this? Is it because of improper experimental techniques, or is it because of the experiment that is supposed to get you this result? Okay, now for QA, the number one most important thing is how you record your observations. And examiners are always looking out how you record your observations. Okay, now the technique for QA I'll run through with you. That means how to conduct the experiment in the fastest and the best manner. And then after that, I will go through with you some of the answering techniques for both the color changes and the precipitate as well as gas evolve. Okay, so we start off qualitative analysis. Most of the time, we will be given test tube. Okay, I teach you exam technique first. I teach you exam technique first. The details about how the experiment is conducted, that one you can read the experimental procedure. Okay, I rather teach you exam technique because all of these can be transferable to different experiments. Okay, now in exam, in O level, you will be provided with a marker, a permanent. You are provided with a marker pen. Now, this marker pen, I tell my students, is very, very important. Okay. The purpose of the marker pen is not there to write your name on your water bottle or your pencil case, but rather it is for you to label, okay, the test tube. Now, how do you do the labeling of a test tube? For example, this is a QA question. There is a part A, part 1, part 2, part 3. Then after that, in A, part 1, there is some form of requirement that requires you to drop in some drops into one test tube. So what I'm going to do is I'm going to write myself over here that here is part 1. Okay, then after that, I pour the solution in. I drop the solution in. Then after that, if let's say that this test tube inside have solution part 2 or conducting for part 2, I will use the marker to write on it. Okay, use the marker to write on it. Okay, so this is the purpose of the marker. It's very, very useful. Okay, don't be scared that, okay, I write on the thing already, will examiner penalize me because I go and damage the test tube. Answer is no. Okay, I don't know whether your prelim, they will give you marker. Some school they do, some school they don't. If let's say prelim give you, normally they will give you with one scotch tape so that you don't damage the test tube. Okay, but for O level, markers will be provided. And every student will receive a new set of test tubes. So please go all out. Draw as long as you know what is happening in your test tube is okay. Okay. You don't need to protect the test tube. Make sure you don't break can already. Okay. You can draw as many things as you want on the test tube as long as you know what you are drawing now, or as long as you know what you are annotating. Okay. All right. Okay. So please label your test tube, okay, to know which part of the experiment you are conducting. Now, in your test tube, students will also ask me, in my QA table, they say white precipitate dissolves to form colorless solution when upon excess aqueous ammonia. Now, what is the term excess actually means? If let's say my solution is until this level, then I say I added aqueous ammonia already. Then it forms me a white precipitate. Okay, white precipitate. Now, the question tell me to add excess, right? So how do I add excess? How much is excess aqueous ammonia? Do I add until here? Do I add until here? Do I add until here? The rule of thumb for excess is actually quite simple. The excess you can add up to 3/4 of the test tube. 3/4 of the test tube, okay? So if let's say the question say excess, add to 3/4 of the test tube capacity. Now, why I say don't add until 100%, don't add until super full, because if I add until 3/4, I can still shake. I shake, I can see whether or not the white precipitate dissolve. If I add until full, have you tried a full water bottle you shake? Does it have any form of movement? I think very don't have, right? So it's important for you to know this, okay? Add until maybe 2/3 or 3/4, both okay. So if you want more, you just put 3/4 lah. Then you try and shake, see whether or not the precipitate dissolve, okay? Now, sometimes students, they add excess, they add very little. Like this is the normal volume, the excess is like that. They add a little bit more, then they try and shake, then the precipitate don't dissolve. Then they ask why. Is it that the precipitate is insoluble in excess aqueous ammonia? Answer is no. Actually, it is soluble, but you need a lot more. You need a lot more. Okay. So chemical in the O level is free. Okay, please pour more, use more. Okay, not telling you to pour in the sink but when you are conducting experiment, you can use okay, use the chemicals. By the way, for students, I tell you again, in O level / prelim in whatever practical exam, if your solution is getting run out already, means you just left a little bit for solution Q, solution P, you need more. Raise your hand, ask for more. They got more supply one. Okay, if you finish using, never mind, ask for more. Okay, no additional fee charge. Okay, you already pay for the exam already, no need to add more cost. Okay, no access charges or no service charge. So they are there to provide you with the apparatus, the chemicals, the reagents needed. Any excess they will not deduct. But if let's say you ask for help, how to do this part, then yes, they will. Okay, based on assistance rendered. But if you need more of any reagents, is okay. Okay. All right. I answered some questions now in the chat. Okay. Before I was talking about the heat loss to surrounding means for thermometer. Okay, when you are conducting experiment for energy changes, when you're measuring temperature, you might use heat loss to surrounding as one of the source of error. Okay. Okay. If both color change and gas are involved, which observation do we write first? Color change or gas? Okay, depends. Depends. If let's say you see the color change first, upon addition, it already color change, then you write color change first. Or if upon addition, there is a gas produced, then you test the gas first, then you write the gas tested first. Okay, whichever one is okay. As long as your recording is there, can already. Will there be extra test tubes or just the exact amount? I heard my friend last year started using the beaker to mix his chemicals. Test tube, this one you need to know. Test tube, they give you limited supply only. They don't give you extra. Okay. Every student has one plastic bag of test tube. And that test tube, that bag probably have like 6 or 8 test tube. Okay, and you can ration it throughout all your different experiments. Okay, just to make sure the QA will be given, QA table will be given. Okay, thank you, Kazu, for answering Mukundan's question. Thank you so much. Okay, Caroline's question, if color change become lighter because it got diluted, do I write no visible observation or do I write color becomes lighter? Because it got diluted, huh? No, then you just leave it, just say no visible change. Okay, no visible change. Unless you are very sure that there is a color change or there is a reaction that undergone, then you write. Okay, if not just no visible change. Okay, or no visible reaction. Junxia asking, must we test for gas while observing color change? If needed to test for gas, how do we tell what kind of gas is needed to be tested? For example, bubbles in test tubes. Okay, so this question is very popular. So what kind of gas am I testing? Now, most of the time, okay, most of the time, most of the time, when you are adding carbonate plus acid, okay, normally they will give you CO2, right? So if let's say that you are asking to add a solid or white solid to a solution, most of the time you can prepare CO2. Okay. If you are asked to have a gray solid, okay, plus a solution, most of the time you will test for hydrogen gas because it's a metal plus acid reaction give you hydrogen gas. So these are some of the rule of thumb. Okay, but non-exhaustive, non-exhaustive these are. Okay. And what are the difference between combined and pure is very different. Okay, this one later, if you want to know, you can ask me later. Okay, at the end. Jiahui, do you need to memorize anything for QA or the sheets provide everything? Okay, as I mentioned just now, the QA table is there as a backup. Okay, you need to know what is happening in the exam first. Okay, that is the number one concern. You need to know what is happening, means how you conduct experiments. But observations wise, you can cross check with the QA table. Okay, so if you are not sure, what am I doing over here? Is the QA table tell you, does the QA table tell you? If yes, then you refer to QA table. If not, then that's not part of the QA already. That's not part of the QA table already. Then you have to do yourself. Okay. How do you know what gas to test? Okay, I've already described over here. Okay, Ingrid. Megan, can I not smell the gas and just test for it? Okay, please don't smell any gas. Unless it's ammonia. Ammonia is a pungent smelling gas. That one you don't need to smell, you can already feel it already. Okay. When you breathe, you can already smell the smell. Okay. Why add aluminum foil to test for nitrate ion? Okay. The chemistry behind it is more technical. If you want me to go through that later, okay, I can go through. But basic of it is just follow your QA table. Okay. If anything you are unsure, if you are testing for a standard ion, follow the QA table is good. Okay. By reading the prompt of gas, can I plan beforehand which gas test to do as I'm unsure when to use litmus or lighter split, for example? Yes, you can. Okay, yes, you can. Now, most of the time, okay, one more. Okay. When there's heating involved, normally it might be ammonia gas. Okay, it might be ammonia gas. Okay, ammonia gas may be evolved after heating. Okay, so these are your three tips. These are the three tips. Okay. The rest of the questions later I will address them. Okay. Let me go through the answering technique first. All right. So for QA, there's a very important one, which is the answering technique. Now, answering technique is very important. It's because of the fact that when you are writing your response, observations wise, you cannot miss out anything. So if there is a fixed framework for you to do this observation, then it's quite simple, right? Because every time you go for the observation, you will always record in the same format. When you record in the same format, it's easy for you to remember. It's easy for the examiner to mark also. Okay, so for answering technique, if there is a color change, this is how your thing will sound like, your answer will sound like. So upon the addition of, for example, aqueous NaOH, write down what is the reagent. Okay, the colorless solution, something like that, right? So this is how you phrase your answer. Whenever there is an action, there should be a before and an after. The key is this: you never give me only the before or the after. You must give me the change. You must tell me what is the change. So you must tell me what's the before, what's after. Okay. This one write down. Okay, this is important. Okay, if you anything you never take home today, most importantly, take home this one. This is the most important one. Okay, the answering technique for your observations in QA. Okay, so upon addition of reagent, a colorless precipitate is formed. Oh, sorry, not a colorless, a colored precipitate is formed. For example, a white precipitate is formed. Okay, light blue PPT, sorry, a deep blue PPT. Okay, deep blue PPT. Okay, a light blue PPT is formed. So write down what is the color observation that you have here. Okay, upon addition of a certain reagent, you get a color precipitate. Okay, now good question. If excess, okay, so this is upon addition, the precipitate is formed. If there is excess, right? So then you can say upon addition of excess aqueous NaOH, okay, the white precipitate dissolves. Okay, dissolves to form a colorless solution. All right, colorless solution. Okay, can okay, so answering technique should be quite simple. Okay, so Aziza and Shari's your question. Okay, how do you say how do you tell when to say bubbling or when to say effervescence? Okay, simple. Don't use bubbling, use effervescence. Okay, Sec 4 already. O levels expect you to use the word effervescence. Effervescence and bubbling is the same thing. Basically, there's gas coming out. Okay, that's what is meant by effervescence / bubbling. But use the word effervescence. Okay, don't use the word bubbling. Bubbling is more of a lower sec concept, lower sec terminology. Okay, Shari's question is, what is the difference between precipitate and effervescence? Okay, effervescence is a gas. Okay, from the test tube, there is a gas that is escaping. That is what I call effervescence. Okay, this is what I call effervescence. But a precipitate is when there is a solid. There is a solid form within the solution. Okay, when I add few drops of a solution to one solution, a small solid is formed. Okay, a small solid is formed, or remnants of solids are formed. This is what is known by precipitate. Okay, how do you differentiate between a precipitate and the solution? Okay, this is a good question. Okay, in Greek question is how do you differentiate between precipitate and solution? If let's say I have a solution like this, how do I know whether or not is it just an opaque solution or is it that it's really a precipitate inside? Key is this: if you don't mind, there is a white towel for your titration. You can pour a little bit on the white towel. Okay, pour a little bit on the white towel. Then you will see. Okay, see whether or not is it really there's bits and pieces inside. Okay, and then that's when you know that it's a precipitate. Okay, now if it is a colored precipitate, that means a light blue precipitate from your copper 2+ ion. What you can do is they will give you tissue paper, right? You can also pour on the tissue paper. Then you can see, does the precipitate separate. Right, the thing get absorbed and then the solution get absorbed and then the precipitate stay there. Okay. Can you write PPT in exam? No, you cannot. You can only write full. Okay, full terminology. By the way, just now I forgot to tell you titration. Inside here, please do not use short form. In your table, no short form. Okay, no short form is allowed. Okay, inside the table. Okay, set a number cannot abbreviate to write no. Okay, must spell out the full thing. Okay. So this is for titration table. Okay, can. Okay, is there a difference between precipitate and solid? No, solid is a general term. Precipitate is when two solutions combine together to give you a solid. That's when you call it precipitate. Okay, so the first answering technique, I think all of us are okay with it already. Okay. Okay. Andy, can you quickly repeat to put to what to write when there's excess? Okay, so answering technique for excess, I'm going to write down for you. Okay, I write down below. Upon addition. So this is for excess. Okay, if I want to add excess reagent, upon addition of excess whatever reagent, okay, one of the two possibilities, either number one, the precipitate remains, okay, number two is precipitate dissolves to form colorless solution. So either one. Okay, number one is precipitate. Tell me what is the color of the precipitate also. Dissolves to form solution. So for example, light blue PPT dissolves to form a deep blue solution. That is an observation as well. Okay. The other one is when the precipitate is insoluble. Insoluble. Okay, so precipitate insoluble, the excess. Okay, whatever chemical it is called. That's it. Can write chemical formula? Yes, you can. Okay, NaOH can write NaOH. Okay, can write NH3 also. No need to spell out full thing. Just that you cannot write short form in terms of precipitate. You need to spell out. Okay. Can. So hydrogen gas evolve, you can just put H2 gas evolve. Can also. Okay. All right, so this is the answering technique for color change and precipitate form. Ingrid, decolorize for which one? For precipitate? Is it for precipitate? Cannot. Because precipitate is a solid. When it decolorize, does it mean that it becomes white or does it disappear? Okay, when the precipitate dissolves, that means the precipitate no longer remains already. The solid is gone. The solid already dissolved to form liquid somewhere else already. Huh? Okay, so that's for precipitate. And then next one, answering technique for gas evolve. This one is important as well. Okay, write down. When we are recording gas evolve, we will always write this. Upon something, upon an action, can be heating, can be upon addition of a certain chemical, colorless, odorless gas is evolved, which extinguishes a burning split with a pop sound. That's hydrogen gas. A colorless, odorless gas evolved, which turns, but, or rather we can say, which extinguishes which relights a glowing split. That's oxygen gas. Then I can say a colorless, pungent smelling gas is evolved, which turns damp red litmus paper blue. Then I know that's ammonia gas, right? So based on this, it is an answering technique. It is a framework for you to fit in what is the keywords for each of these factors. So for example, gases, you must tell what is the color, what is the smell. So is it colorless, what is odorless? Okay. Andy, what if nothing happens? Nothing happens means either there is no gas evolved or your gas that you're testing is not correct. Can. Now, what are the signs that shows the need for oxygen test? Actually, oxygen test and hydrogen test is very similar one. Hydrogen test, you put in a lighted spleen, right? You put in a lighted spleen, it extinguish with a pop sound. Now, oxygen test, when you put in the lighted spleen, you see if the flame become bigger. If the flame become bigger, normally, yes, we say it relights a glowing spleen. That's correct. But can you see, if let's say that I have a spleen over here, then the spleen is lighted. I put inside oxygen, a region of high concentration of oxygen, that means that the flame will burn more, right? The flame will burn more. So instead of the flame getting extinguished, it burns brighter, it burns larger. There is some sort of mini explosion involved. Not really explode, but there's an enlargement of the flame. Then you know that that is when oxygen is released. Okay? Yeah. Okay, Andy, yes, rekindle a glowing spleen. Oh. Okay, so this one is for gases. All right. So you need to know what is the answering technique. So you need to tell me for gases, what is the smell? What is the what do you see? Right? Is it colorless? Or is it there's a color to it? Okay. For example, when we are looking at iodine gas, iodine gas is a purple vapor, right? So you can see a purple vapor is formed, something like this. Okay, very good. Thank you so much for asking questions. Keep your questions coming. Very interesting questions from everybody. Okay, any other questions? If you got no questions, can you give me a thumbs up? Then we'll move on to the one that everybody has been waiting for today. Okay. All right, Christabel, I have a question. Is the test for hydrogen and oxygen basically the same? Yes, yes. Okay. Basically the same. In theory, no. Okay, but in practical, yes. Okay, what do I mean? In theory, oxygen gas is you put a glowing spleen. A glowing spleen, if the glowing spleen relights, rekindles, a flame comes out from the glowing spleen. The glowing spleen means what? Glowing spleen means there is no flame one, but just that the tip of the wooden satay stick is very red. Okay, it's like semi-burning, but there's no flame. Then when you put it in to the region of high concentration of oxygen, what happens? It starts to explode. There's a flame that comes out, and that's when you know oxygen gas is present. But hydrogen is different. Hydrogen, you use a lighted spleen, a burning spleen. You put inside a region of high hydrogen, it will extinguish with a pop sound. Okay, can okay. Aziza, what if you really lost, don't know what gas to test? Are there any visual signs? This one, okay, you need to know, as I mentioned, you need to know what is the experiment that you are conducting. So based on my recommendation just now, that these are the different scenarios. If let's say you are asked to add white solid to solution, it's probably a CO2 gas. Gray solid to a solution is probably hydrogen gas. When there is heating involved, of two solutions that put together, normally is ammonia gas. Okay? We also need to light the spleen also using the lighter, but just extinguish it before putting it into test. Yes, that is for oxygen. Shari is correct. That one is for oxygen. But for simplicity's sake, for practical, right, we just use a lighter spleen. It's easier. Okay, it's easier. Either the lighter spleen goes out or the lighter spleen doesn't go out and burns brighter. So you know it's a hydrogen or oxygen. Okay? Normally school don't teach you this because by right not supposed to do that because you cannot really see the observation. But you put in, you can see one the flame burns brighter. So you know oxygen gas is being evolved. All right. Can Okay, now we move on to the last part for today, which is on planning question. Okay, I know everybody have been waiting for this. Okay, so mean for you. Yeah, so sometimes when you are reading planning question, you will come across confusion. Okay, it's very, very easy to come across confusing questions in planning. Now, planning questions can have, the reason for this is um, planning questions have a very wide range of topics that they can test, very wide range of factors that they can ask as well. So it requires your knowledge for all practical topics, some theory topics even, and chemical reactions as well. Okay, Andy, your question, yes, combine also need, but sometimes combine chem will have small questions, sometimes we have long question. Okay, sorry, this is for you. Okay, Mel, to take a photo of this page. Okay, Sharice, what are the signs of ammonia? Ammonia is a pungent. pungent gas. Okay, very pungent gas. Okay, turns red litmus paper blue. Can Mel, okay, okay, good. Okay, back to this planning question, as I was saying. So, the whole premise of this is that planning questions are sometimes very scary to students. It's because the question is not uh, straightforward, right? It needs you to think, it needs you to be creative, needs you to think about a solution to the question itself. And the question can have many types. Some is a confirmatory type of question, which means I confirm that a gas is being produced in this reaction. Those are confirmatory type of planning question. There are some type of planning question is investigative type of planning question, which means I compare concentration against volume of concentration against a certain reactant. So when I increase concentration, does the rate of reaction increase or does it decrease? This is what we call investigative one. Investigative means whether or not we use a certain factor, we change some stuff in that factor, does it give us the result that we expect? Oh, okay, so this is for planning question. You can see many students will have this face after you read the planning question itself. Okay, now, but not to worry, okay, I'm going to teach you a method today to dissect planning question. Okay, now, this is what I call the AVPD method. Okay, some of my students call it a very pretty donkey method. Okay, so just anything to make you remember. Give you a photo of a pretty donkey here. Okay, so for planning question, I'm going to introduce this to you. It's called the AVPD method. Now, I will tell you what does this AVPD means, and I'm going to demo to you on a planning question and how it's being used for that question in itself. Okay, so I hope that you can follow through with me for this question. Okay, so what is AVPD? It is a framework that I've created to help you, okay, understand planning questions better, help you to approach the planning question better. Okay, my students, if you are my student already, you know lah, or if you have attend my lesson, but for those of us who, for the benefit of the rest of us who haven't seen me before, okay, I explain to you what is AVPD. Okay, now, A in AVPD stands for approach. Okay, so what is approach? Approach is what is the method, okay, that you are going to use to approach the question. Okay, so that means that if let's say that we are looking at a rate of reaction question, are we measuring mass loss over a period of time? Are we measuring volume of gas evolved? Okay, so these are some of the things that we think about when we talk about approach. Okay, now later I will show you what does this actually means lah. So what is the strategy that we use to solve the question? So that is what is meant by approach. Now, V stands for variables. Okay, variables are. Now, can anybody tell me in the chat box, what are the 3 types of variables that we have? What are the 3 types of variables that we study? Yes, thank you, Mukundan. Okay, so we have this thing called the independent variable. Number 1, we have independent variable. Okay, we have the dependent variable. And then we have the constant variable. Okay, now the independent variable is the one that I intentionally change. Okay, this one is what you decide based on what the question wants. So for example, I am investigating the effect of concentration on a certain rate of reaction, then the independent variable will be the concentration of that solution, because that is what I intentionally change, but I'm trying to get a result on that. Okay, so if when I have a independent variable, the dependent variable will be the one that is affected, the result that is affected by that. So for example, concentration of a solution that is talking about speed of reaction, right? The dependent variable can be the volume of gas. Sorry. This one is, sorry, I give you an example first. Okay, so this is measured Okay, result. So it can, for example, be volume of gas produced. This can be a dependent variable. Okay. Then constant variable is the stuff that I keep constant every time. So for example, okay, like the volume of solution used. Okay, so I change concentration, but I keep the volume constant. Okay, something like that. Can I? So this is A and V, approach and variables. Now, can anybody guess P stand for what? The AVPD. A stand for approach. Okay, Mukundan close. Okay, process. Actually, say property. Okay, not really. Yes, Chloe, you got it. Okay, procedure. Okay, the P in AVPD stand for procedure. Okay, so in the procedure, okay, you need to write down what are the steps required to conduct the experiment. And this will be the most important one because majority of the mark will go to the procedure. Okay, normally it's a 4 mark or 5 mark planning question. The 1 mark will always go to the diagram if there is a diagram involved, or description of drawing a diagram. Then the procedure will normally be 2 marks. And then after that, the last part will be the 1 mark left. Okay. Now, the AVPD, the D stand for data interpretation. Okay. Some of my students, if you with me for quite some time, D stand for data processing versus data interpretation, both the same thing. Okay. Data interpretation is more so for graph lah, to present your solution in terms of graph, in terms of a conclusion. Basically, I'm trying to use the result to draw a conclusion. Okay, use a result to draw a conclusion. Can I? Use a result to draw a conclusion. Basically, to prove whether or not the what they are investigating is correct. Oh, okay. So this is called AVPD method. For any practical planning, you can use it. Okay, to dissect the question, to help you understand how you are going to approach the question and answer the question. Okay, approach variables, procedure, and data interpretation. So some students call it a very pretty donkey. So on the right hand side over here. Okay, just remember AVPD for practical planning. Okay, are we good? Yeah, I'm gonna show you in a minute on how we apply it on a question. So if you need to take a picture of this, please take a picture of this. Okay? Yes, Kazu. Just give me 2 more minutes. I will go to the method of answering this question, using this method to answer question. Okay. Can everybody managed to take down this already? Okay, I will move on to the question. Okay, this is a sample question. Okay, give the question a read first. Okay, think about the question. Go and read this question. Okay, can I read the question already? So I have P and Q. Yes, Li Guo, yes, correct. Okay, planning is included. Okay, but sometimes combined chem might not have a lot of planning. Okay, sometimes maybe it's a 2 mark, kind of suggest a way for you to investigate. It's not really a full-blown planning question. It's more of a mini planning. Yeah, okay, so combined chem, the planning can occur in both practical and your written paper. Okay, your paper 5. Okay, now let's look at this practice question. Okay, so I have P and Q. So P is 2.0 moles per dmq of hydrochloric acid. We know that Q is 2.0 moles dmq of an alkali, which has the formula either XOH or XOH2. Okay, so this one over here, they give you these two. Now, we have learned that different types of acid have different basicity. For example, like HCl is monobasic acid, H2SO4 is a dibasic acid. Okay, so in the similar context, when I'm looking at bases, at alkalis, when they have XOH and XOH2, this is what we call a diacidic base or monoacidic base. Okay, we call it dibasic acid, right? Now it's diacidic base. Basically, it is swapped over, but it's talking about how bases, does it give me 2OH minus or 1OH minus, uh, 1OH minus, okay, whenever I am dissolving in water. Okay, so they are trying to establish what is the correct formula. Is it X or Y? Sorry, is it XOH or is it XOH2? Okay, so how do we approach the question? Can anybody tell me what is the method that we use for this question, or what is the overarching principle for this? If you see a question like this, let's try using the AVPT framework. Okay, Chloe said titration. Anybody agree? Anybody agree? Liko said agree. Andy, your question is planning included in both pure and combined, is it? Yes. Answer is yes. Okay, Brandon says titration. Okay, good. Who else agree titration? Anybody have different one? Aziza, this kind of question they will ask for combined. Unlikely. Okay, unlikely. This one is more of a pure kind of question. Okay. Normally combined chem planning is very simple. Okay, combined chem planning is very simple. Okay, Izati say titration. Okay, so the approach for this question will be a titration method. Okay, titration method. Okay, so how does this titration actually works? We are trying to titrate. Okay. Okay, wait. Titrate what? Titrate P and Q, right? So we are using P and Q as a titration. Okay, titration method. Now, so this is the approach. We already got the approach down already using a titration method. This is the biggest hurdle. Most of the time, students don't know what is the approach. Because you read the question, you don't know what is the strategy to approach the question or what is the method used for this kind of experiment. Okay, now once done, approach is done already. Now we go to V. What is the variables? Okay, can anybody give me what is the independent variable? If you are using a titration method, what is the independent variable? P and Q both independent. The independent variable is something that I fix or something that I purposely change. Okay, volume of Q. Okay, can. So we use volume of Q as the independent variable. So I fix the volume of Q. Okay, now if I am using independent variable as volume of Q, right? It is a reading that I need to measure fixed. Then in this case for a titration, do I put it in the pipette or the burette? If volume of Q is something that I decide on, I fix it. I fix the volume. I don't want to change already. I use a fixed volume. Yes, Grace, you are right. Okay, Wingyu, yes, IV can either be P or Q, up to you. But in this case, we use Q as an example. Okay. Yes, thank you, Chloe. Now, the reason for using a pipette is this. Now, independent variable requires me to decide a certain volume, right? That means that the dependent variable later on will be the one that is affected. So if you think about it, the dependent variable will then be the volume of P used. Am I right? Because volume of Q I decide, my volume of P is the one that is going to change now. So if I'm going to, volume of P is the one that I'm going to change, that means that one I need to use the burette for it. because burette can give me different reading, can on off the tap and give me different reading. So volume of Q, I will design to be a fixed volume using a pipette. Okay, that will be the IV and the DV. Can I? Okay, so volume of Q is in the pipette. It's used to measure by the pipette. And then burette is used to measure volume of P. Okay, so I'm going to draw a diagram for you over here. Conical flask. Inside conical flask is going to be Q, 25.0 cm3. Okay, we dot stat my burette over here. Oops. Okay. Okay, this is my burette. Okay, so in the burette is going to be P. Okay, P is in the burette. So I'm finding out how much of P is required to neutralize a fixed volume of Q. Huh? Okay, so that will be the variables. Okay, Chloe, yes, your answer yes. Okay, can. So this is one of the method. We put Q in the conical flask and P in the burette. So I'm going to measure how much P is required to neutralize a fixed volume of Q. Okay, now with this understanding, okay, what is the control variable? Is there any control variable for this case? I think don't really have any control variable, right? ND is short form allowed, right? IVDV. No, it's not allowed. But actually, in the question itself, in the procedure, you don't need to write IVDV. Actually, you just need to show this part. You just need to show this part. Procedure and data interpretation. A and V can be rough working. Okay. They don't need you to specifically write out what is the independent variable, dependent and constant, because your procedure will already encompass that. Later, I'll show you what do I mean. Okay. If you want to show it out, yes, you must write in full form. Okay. But if you go by AVPD framework, okay, so approach and variable done already. Constant variable, I don't think there's any because in this case, it's a very simple experiment. Now we go on to the procedure. Okay, so for procedure, I'm going to show you how is a procedure being written. Okay, so let's look at this procedure together. Okay, I'm going to zoom in. Give me a moment. Let me zoom in this. Okay, so let's look at this. So just now we discussed, okay, that in the burette, it will be solution P. And then in the conical flask, it will be solution Q. It is slightly different from my answer over here. Okay, so in the procedure, I will write fill the burette with solution P. Okay, pipette 25 cm3 of Q into conical flask and a few drops of methyl orange. Okay, this will be my procedure. Now, Chloe, yes, only physics need to write variable. Chemistry don't need. Chemistry, you just need to show this. Procedure and data processing. Okay. I'm just going to use this method, right? Okay, to show you how to use AVPD. Okay, to do this. Then after that, when you go back, you try on your own planning question. Can Okay, so let's look at this on step number 2. So prepare 25 cm3 of Q into a conical flask and add a few drops of methyl orange. Then titrate Q against P until endpoint is attained. So in this case, do you know procedure over here? You don't need to tell them rinse the burette with the chemical, prepare a solution or whatever, all this no need. You just need to go straight to the point. Use the triple A method. Okay, one more acronym I share with you now. Triple A method for procedure. Okay, this one is important also, the triple A method. A stand for action. A stand for accuracy. A stand for apparatus. Okay, so what is action? In this case, for example, I take step 2 as an example. So every step must encompass these 3 things: action, accuracy, apparatus. So action is this, pipette. Okay, pipette using what? Okay, a pipette lah. Okay, pipette. What is the accuracy? 25.0 cm3 of something into a conical flask. This is my action. Okay, so you need to have these 3 things: action, accuracy, apparatus. All right. Okay, later with you, I will answer your question, okay? Then after that, in step number 3, titrate P against Q, etc. And then after that, yes, this is the one. Okay, now, if you are going to repeat the experiment, you don't need to draw a table of results for them. You can say, record the titration results in a suitable table. That's enough. Okay, can already. You don't need to draw out for them what does the table look like. And then you just say, repeat the titration until consistent results are obtained. And then under burette reading, data processing. So once we have conducted the experiment finished already, we go on to data interpretation. That means that based on the result that we have, how do we make sense of the data? So from the burette reading, calculate volume of Q neutralize 25 cm cube of P slash, or the other way around. The other way around would be to use volume of P completely neutralize Q. All right, both also can. So if the volume used is 25 cm cube, means it is a monoacidic base. If it's 12.5, means it's diacidic base. Okay, because volume of Q, okay, if it's 12.50, which means that the concentration of OH minus is double. Okay, hence it's XOH2. Okay, so this is how you use the AVPD framework to try and do a question over here. Okay, so if you want, you can take a picture of this question and then you go back and read the solution. Okay, all right. This is mainly for pure chem. Yes, that is correct. When you your question on methyl orange, endpoint should be between 3 to 5, then the solution is not neutralized. Okay, so endpoint is a concept that we are using to estimate, okay, to estimate the point whereby the solution exactly neutralize the acid exactly neutralize the base. Okay. So the methyl orange is a type of indicator that helps you to find that point. Okay. Andy, your question usually combine us for what in this type of question? Okay, usually combine chem planning questions it will ask energy changes. Actually, very combined chem questions are quite simple, and they will ask you planning is, for example, if you're conducting a type of experiment, what can you suggest to make the result better? Then that will fall on the concept of sources of error to help you plan a new experiment. Okay, it does not require you to design an experiment from scratch for combined chem. Normally, it is a suggest an improvement or suggest another method. Okay, sort preparations for pure chem. Okay, for combined chem, maybe it's talking about speed of reaction, energy changes. Okay, can okay, so this is for the AVPD framework. Okay, so approach, the variable, the procedure, and then the data interpretation. Okay, so these are the 4 factors. Can. Okay, Andy, you try for pure bio, then you let me know whether it works. Okay, but this method is tested and proven for chemistry planning. Okay, the AVPD method, to help you to break down and dissect the planning question into 4 different sets of instructions. Okay, can Okay, so with that, that is the end of the planning segment. I will now share with you, okay, this is very one thing that students always want. Okay, I'll share with you a summary on this. Okay, summary of some risk and precaution for you to take. If let's say the planning question have this pointer, they say, what are some precautions that you should take? 1 mark. Normally it's 1 mark. Okay, precaution you need to take. Just take a screenshot of this. Okay, if you need this one, you take a screenshot and then you set as your phone wallpaper. Okay, then after that, every time you on your phone, you read, okay, what are some of the summary, what are the risks and precautions to take for exam, okay, for planning question. So I run through it with you very quickly. Okay, so summary for some broad hazards. Firstly, if let's say I have something that is oxidizing, for example, an oxidizing agent, what are some of the impacts? They might be poisonous, corrosive, and flammable. This one you just listen. Okay, you take a picture of it already, you can just listen to me. Now, for flammable, they have low flash point, which means very fast it will burn. Okay, for example, volatile liquids like ethanol. Corrosive, For example, acids and alkalis, especially strong acid and strong alkali, they will cause skin burns, acid burn. Okay. General safety precautions wise, okay, for general heating, do not leave Bunsen flame unattended. Another thing, Bunsen burner, please wear safety goggles. Okay, please wear safety goggles. Heating of flammable substances, heat over a water bath instead of using a direct flame to avoid the scenario where the flammable substances catch fire. Reactions with produce irritant gases, do not point the test tube at somebody's eyes, okay, because the irritant gases might go inside the eye. Okay, and using of glassware, do not use cheap or broken glassware. Okay, so these are some of the risks and precautions you need to take for planning question. Okay, does anybody have any question for this? No question. If all good, can you give me a thumbs up? Can I? Okay, so okay, I'm waiting for somebody to ask this. Okay, Chloe's question. Will Pure Chem practical test on organic chem for planning? Planning organic chem, if they want to test, they can test. But what can they test? They can only test this bromination reaction. How do you separate a sample of alkane from alkene? That's the max that they will test. So how do we use? We drop aqueous bromine, and then we see whichever decolorize is an alkene, whichever doesn't decolorize is an alkane. That's simple. Okay. For organic chem planning, is very simple. Normally, it'll be 2 to 3 marks. Okay. Now, practical wise, organic chem for experiments, they can appear, but very, very rarely. Okay, very, very rarely will appear because the logistic required to set up organic chem practical is, yeah, it's very painful. Yeah, normally they will ask you to test for saturation. Okay, if let's say they were to come up for organic chem as a practical for pure chem. What did we learn from today's session? We have learned, number one, key practical topics and skills revision, right? We went through what are some of the common mistakes of the topics today. We have moved on to talk about the learning pointers of common experimental topics, for example, titration, speed of reaction, energy changes, etc. Then we also move on to how to approach difficult planning questions with the AVPD framework. Okay, so if that method actually works for you, you can also adopt that method when you are doing your planning questions as well. And I've also shared with you what is a plan for success for prelim and O level. If you are keen, you can join us for our last lab program. Yes, combined chemistry can also be arranged. All right. Yeah, over here. Okay, thank you, Jin Xian. Bye bye. Thank you, Jia Hui.